Hello students, this is Genius Prozamia. So in this video, we're going to look at questions from 2019 Science, paper 1. That is question 1 up to question 7. So be quick, just need to look at how we can go about solving different questions. So let's begin. So the first question, A1, says, the diagram below shows 4 identical metal bars placed between 2 wooden blocks on a ruler. So we have these 4 identical metal bars, 1, 2, 3, 4. Then this is simply a ruler that was placed between, the metal bars were placed between 2 wooden blocks. So the question says, what is the diameter of one metal bar? So we want to figure out the diameter of one metal bar, meaning what's the length. For example, this metal bar, what is this length? What is that length? That's what we want to figure out. So from the ruler, we can clearly see that the division for one step is simply 1. So this is 1, 2, 3, 4, 5. So if we can find the distance from this point all the way up to that point, we can divide by the 4 blocks because we have 4 of them to get the average length for one block. So first of all, let's measure the distance from this point all the way up to this point. So here, this is 4 centimeters. Then here we have 16 centimeters. So from there up to there, since here we have 4, then here we have 16. So we can clearly see that from there, from this point up to that point, that is 6 centimeters minus 4 centimeters. That is 12 centimeters. So the length for all the 4 metal bars, that is 12 centimeters. But what we want is the diameter for one metal bar. So we're going to assume that these metal bars are of the same diameter. They are identical. So the diameter for one metal bar will just be the total length, which is 12 centimeters, divided by how many are they? There are 4 of them. So that would be 3.0 centimeters. So this corresponds to answer choice C. So answer choice C is the correct answer. So A2. Which of the following would change the period of oscillation of a pendulum? So, a pendulum, we can have a string. Then to this string, we just attach a bulb, this metal ball. It could be metal ball, wooden ball, anything. This is just a small ball of known mass. So this is simply a bulb. So we can allow this to swing. Now, there are some factors that affect the rate at which this swings. So one of these factors that affect the period of the pendulum, the time it takes to make one complete oscillation, that is for it to go there, to swing back and forth. So for it to move from there, if you start it from here, it has to go from there, then it should go back. That is one complete oscillation. Now there are some factors that affect the period of the pendulum. One of them is the length of the string. So this length would affect the period of the pendulum. The other one is the gravity, the gravitational field strength. Gravitational field strength would also affect. The other one is the amplitude, the angle at which you position the bulb would also affect. One thing you should know is that the mass of the bulb does not affect the period of the pendulum. So according to this question, answer choice B is the right answer. Mass of the pendulum would not change. But the question, which of the following would change the period of the pendulum? Okay, so the mass of the bulb would not change. It does not affect the period of the pendulum. The length affects the period of the pendulum. So the answer to this question, which is A2, is simply answer choice C, the length of the pendulum. This would affect the period of the pendulum and hence change it. So that's the answer. C is the right answer. A3. The diagram below shows a graph showing the movement of a car over a period of 70 seconds. So a car starts from rest, then it moves and it takes 70 seconds to cover the entire distance. The question is, what distance was traveled by the car while its speed was decreasing? So when we look at the motion of the car, we have 2 parts. There is part A, so we have something like this. There's part 1, part 2, or part 3. So in this section, the speed is increasing. You can see that the graph goes up, the line slopes up upwards. So the speed is increasing. So since the speed is increasing, the body is said to be accelerating positively in this section. Then here the speed is neither increasing nor reducing. So the body is not accelerating in part 2. Then part 3, we can see that the straight line now slopes downwards. So since the straight line slopes downwards, we say that the speed is reducing. So the question asks us to find the distance when the speed is reducing. So we want to find the distance in part 3. So if you have a speed time graph, for you to find this distance covered, you need to look at the shape of the section that you have. So in this case, we just want to find the speed when the car had decreasing velocity. So we just want to find the speed, the distance in the section 3. So section 3 is a triangle. So what we need to find is the area of a triangle. When we find this area of the triangle, that will be the distance traveled in section 3. That's what the question is asking us. So let's find the distance. So recall that area of a triangle is simply half base times height. So area is half times, so it's this part. So remember here there's 70 because the total distance this time was 70 seconds. So here there's 70. So we have 60 here, we have 70 here, meaning there's 60 there, there's 70 here. So the base is simply 10. The difference, 70 minus 60 is 10. Then times how high the triangle was. So from there up to there, we can clearly see that this length is 20 meters. So by 20. So area will be 2 there 1, 2 there is 10. 10 by 10 is 100 units squared. Therefore, the distance is simply 100 meters. So answer choice A is the right answer. Okay, so A4 says the diagram below shows a 200-gram object on which was on a frictionless surface and was acted upon by 3 forces. So this is this surface is frictionless. There's no friction. Then the mass of this body is 200 grams. There's a force 6 newtons which is directed to directed west. We also have the 2 Newton force directed to the right. We also have the 5 Newton force which is directed to the right as well. The question is, which of the following is correct about the acceleration and direction of the movement of the body? So we need to figure out the acceleration of this body. What we're going to use is something called Newton's second law of motion. So Newton's second law of motion says the net force that acts on a body is proportional to the acceleration. So if you have a body, let's say this net force, let's say you have 600 newtons pushing this body, the size of this force, the size of the force will produce a certain acceleration in its direction. So if I have a 600 Newton force acting on this body to the right, it will produce an acceleration towards the same right. So here I have a 6 Newton force, I have 2 newtons there, 5 newtons here. What I need to find first of all is the net force. So net force, here we have 6 newtons. So let's come up with the sum of all the forces. So this is to the left, so I'll take it as a negative. So this is negative 6 newtons. So I'll treat the left side as negative. Then plus this is to the right, so plus 2 newtons, plus this, which is 5 newtons. So the net force is negative 6 plus 2, that is negative 4. Negative 4 plus 5, that is 1 newton. So this is our net force. Now we need to figure out the acceleration. So from Newton's second law of motion, we can see that net force is equal to mass multiplied by acceleration. So acceleration will simply be the net force divided by the mass. So acceleration, the net force is simply 1 newton divided by the mass, but this mass has to be in kilograms. So we have 200 grams. To convert to kilograms, just divide this by 1,000. That will be 0.2 kg. So 1 divided by 0.2 kg. So you can simplify by saying by 10. This by 10, this will be 10 newtons divided by 2 kg. So acceleration is simply 5 meters per second squared. But take note, our net force was positive, an indication that it was directed to the right. So acceleration is positive 5 meters per second squared, and the direction of this acceleration is to the right. So the question, which of the following about the acceleration and movement? So the answer is C. Acceleration is 5 to the right. So let's go to F5. Why would a mechanic prefer to use a longer spanner to loosen a nut than a shorter one? A longer spanner would. So if you have a spanner, then you have a nut somewhere there, then you want to loosen it. You can apply a certain force here. Let's call it. Then let's have another spanner that is shorter than what we've just drawn. Then it's also doing the same work. So we apply the same force here. We apply F there. Then we want to tighten or loosen, in this case, want to loosen the nut. So there will be a certain distance here. We can see that this distance this is the point of axis of rotation. So this is the distance between the axis of rotation and where the force is being applied. So this force will cause some turning effect on the same nut, and it will enable you loosen the nut. So that turning effect is what we call torque, or moment of a force. So moment of the force produced by this force, which is torque, moment of a force, is simply the force, which is F, times the distance from where it's been applied to the axis of rotation. So times distance. This is the distance. This will also produce moment, which is torque. So torque will be the force that we apply multiplied by the distance. But we can clearly see, since these forces are of the same magnitude, but the distances, this distance is larger than this distance. So because this is being applied at a longer distance as compared to this force will produce a greater turning effect. So a longer spanner produces more turning effect, a greater turning effect. So the advantage of you producing a greater turning effect is that you loosen the nut more quickly than, or you just need less force to do work than this one would need. So this one, because the distance here is shorter than the distance here, you're going to have a less turning effect. As a result, it will be more difficult for you to loosen the nut as compared to this person who is using a longer spanner. So a longer spanner enables you to loosen a nut easier by producing a greater turning effect. So a longer spanner would give a greater turning effect. So answer choice B is the right answer. That's all. A6 says a drum of water of weight 200 newtons. So the weight is 200 newtons. Is rolled up a plank of length 2 meters. So this plank is simply 2 meters into a platform of height 0.8 meters. What is the work done on the drum against gravity? What you should know is that work is simply force times distance. So we need the force. Now the question is, what is the work done against gravity? So it's like you're doing work against gravity. Take note, I have something like this. We have 2 meters here, then the height there is 0.8 meters. So we know that gravity acts downwards. So for you to do work against gravity, what it means is that there is a gravitational force that is doing work. Then this work done against gravity is simply equal to the gain in gravitational potential energy, which is just mgh. Because what you would need is the height, the weight of this body. Because the weight, which is the pull of gravity, is mg. They multiplied by the height here. So you're going to have, this is the weight, which is the force. Then you need the distance. In this case, the distance is the vertical distance because you're doing work against gravity. So you need the vertical distance, which is the height. So you're going to have mg multiplied by height. So work against gravity will just be mgh. So what is the mass? We don't know the mass, but we're given mg. Mg is the weight of our body, our drum. So the weight is simply 2,000 newtons multiplied by the height, which is 0.8 meters. So we have 2,000. So So we have 2000 newtons multiplied by 0.8 meters. So I can just have 8 times this, that will be 16, so I have 16,000. Then I have a point here, decimal point will just come there, so then it will be 1600. So 1600 joules. So this is how much work was done against gravity. So that's the answer. So this corresponds to answer choice B. A7 says a crane lifts 600 kg mass through a vertical distance of 12 meters in 8 seconds. What is the crane's power output? So you should know that power is simply work done over time taken. Power is the rate at which a work is done. So we need to know the work. Here a crane lifts a 600 kg mass. Then we have a vertical height of 12 meters. Then the time taken is simply 18 seconds. So this work, since you are lifting up something, this is the work done against gravity, which is just the gaining gravitational potential energy. So let's just find the potential energy, which is the work. So work is mgh. So the mass is 600 kg. The gravity is 10 meters per 10 newtons per kg, multiplied by the height, which is 12 meters. So what we can say is this times that is 6,000 multiplied by 12. So let's multiply this together. So we have 0 there, 0, 0, that is 12. That is 0, 0, 0, that is 6. We have 0, 0, 0, that is 2 of 72. So the work done was 72,000 joules. Now this work was done in a period of 18 seconds. So we can now find out what the power is. Power is how much work is done divided by the time taken. So the amount of work that was done is simply 72,000 joules divided by 18 seconds. So 18 there is 1, 18 there is 4. So we have 4,000 joules per second. So a joule per second is the same as 4,000 watts. So this corresponds to answer choice A. Answer choice A is therefore the right answer. Thank you for watching this video. This is what we had for you guys. Don't forget to like our page. Invite your friends to like our page so that they don't get to miss any of our videos. Thank you. Genius Pro Zambia.